Hi everyone. In this video we're going to start talking about how to measure variability relative to the median. A quick review of measures of center. We learned that our two measures of center that we use are the mean and median. Intuitively, the mean balances the negative and positive deviations. All of the signed distances below the mean and above the mean cancel out to zero, and the median is the physical center of the distribution. As far as how to calculate it, the mean, denoted x bar, is the sum of all the x values divided by the number of individuals n, whereas the median is the 50th percentile. So in other words, you have to take 50% of n, the total number of values, and from there use the techniques for finding a percentile to find what the median value is. One of the biggest takeaways is that we use when the data is roughly symmetric, that is when we are allowed to use the mean, and when the data is skewed, that is when we have to use the median. The reason being, when the data is skewed, the mean becomes an unreliable measure of center because it becomes skewed too much by the outliers, if there are any, or the skewness to one direction or the other. So the median has to be used as a measure of center. When the distribution is symmetric, the mean and median are roughly similar, but in those cases the mean is preferred because it has many calculation advantages and mathematical advantages. Okay, so when we have a distribution, we determine its shape, which then determines whether we use the mean as our measure of center or the median as our measure of center. Okay, so now where we're going to now is talking about measures of spread or variability. Okay. So spread or variability is the idea of how spread out the data is, or how condensed together the data is, how close or far the data tends to be from the center of the distribution. Now, as we see, we have different choices for the center, and so when we make our choice for the center, that will determine how we look for the spread or the variability. Okay, so when we have the mean, we're going to use a completely different set of rules and calculations for finding the spread or variability compared to when we use the median. Okay, so what we're going to focus on now is the median. Okay, when we use the median as our measure of center, we measure the spread relative to the median using what are called quartiles. Okay, so let's get into what quartiles are. By the way, throughout this video, at any point, you need to take a moment, pause it, and take your moment and make sure to be taking notes as well. Okay. Quartiles. Okay. So first, the definition. There are three quartiles. The first, second, and third quartiles, which we denote Q1, Q2, and Q3, correspond to the 25th, 50th, and 75th percentiles. Okay, so the work we did on finding the percentiles, that's the work we're going to do to find the quartiles. Okay, so the quartiles is just a particular name that we assign to these particular percentiles. Okay, for perhaps obvious reasons, right? The name and the actual percents, you should probably see the connection, right? Quarters make up 25%, 50%, and 75% of a whole, right? If we have 1, 2, or 3 quarters. So that's where the name comes from. Okay, so these particular percentiles are very important, and they help us understand spread relative to the median. So let's, okay, so just another, to make it very clear, Q1, the first quartile, is the 25th percentile. Q2, the second quartile, is the 50th percentile. Q3, the third quartile, is the 75th percentile. By the way, Q2, the 50th percentile, of course, is the same as the median. Okay, so this is exactly the same as the median. Okay, so now we have two names for the median. All right, so now the quartiles are so important that they help us summarize the data into what's called a 5-number summary. So when we talk about the 5-number summary of a distribution, we're talking about these 5 values here, right? So any distribution we have a minimum value in our distribution, we have a maximum value, and we have the 3 quartiles along the way. Okay, so anytime we have a distribution, we can find its 5-number summary. And as we'll see throughout our lessons, the 5-number summary is very useful in trying to understand the distribution. So let's jump into an example. Find the 5-number summary of the following list of values. Okay, so here I have a list of values written in order, and I want to find its 5-number summary. Okay, so we're not attaching any context to these for now, just so we can practice the technical work. Okay. So, if you're comfortable, pause and try to find the 5-number summary based on the definition above. Okay, just do your best, see what you can come up with. When you're done, go ahead, unpause. Okay, and we're back. So let's talk about how we would do this. Well, first of all, it might be useful to identify these as the following, right? The first value, the smallest value, let's call it x1, then x2 is the second value, and so on. So we see that we have 10 values in this list, right? So my n is equal to 10. All right? So to find percentiles, remember the very first step is always to take the percent and multiply by the number of values. So if we want to find the 25th percentile, what we have to do is take 25% and multiply by 10. And then, depending on whether we get a whole number or not, that tells us how to proceed. Okay, so let's look at the 25th percentile. Again, make sure you've tried this before you look at the answer I'm about to show you. Okay, so 25% of 10 is 2.5. Okay, when you don't get a whole number, what you do is you round that number up to the next whole number, in this case, 3. Now, most common mistake here is to think that the percentile we just found is equal to 3. That is not correct. Again, notice none of these values are that small. Okay, the smallest value is 15. The number we get here is only telling us where to count to in this list. Okay, so when we round up to 3, it tells me that the first quartile, or the 25th percentile, is equal to whatever value is the third individual from the left, the x3 value. So if we just look right at our labeling, or if we just count it, 1, 2, 3, there's our third individual from the left. So the quartile 1 value is 17. Okay, so again, 17 is a number where about 25% of the data is smaller than it. Okay, that's what that means. All right, now the 50th percentile. Take 50% of 10. We of course get 5. Okay, but when you get a whole number, the rule is different. When you get a whole number, then the percentile you're looking for is between, in this case, x of 5, the index we got there, and x of 6, the next value. Okay, so when you get a whole number, again, you look to the halfway point between these two middle values, x5 and x6 in this case. Okay, so the two numbers I get is 22 and 25. If I look here in the list, the 5th value is 22, the 6th value is 25. So I need a value that's halfway between 22 and 25. So I think it's 23.5, but we can check by just averaging them. Okay, so the second quartile, aka the median, is going to be the average of these two middle numbers, which will give us our halfway point. 22 plus 25 over 2 gives me 23.5. Okay, so again, 23.5 is the number that's halfway between 22 and 25. Okay, and then finally the 75th percentile, take 75% of 10, get 7.5, that's not a whole number, so I round it up to 8, which tells me that my third quartile is at the 8th value from the left, x8. Okay, and so we can look at how we listed them here, or we can just count 1, 2, 3, 4, 5, 6, 7, 8. Okay, x8. 32. Okay, so I found my quartiles. My minimum and maximum are just my smallest value and my largest value. So that means my 5-number summary is the following: 15, 17, 25, 32, 42. Okay, so I'm going to stop here and I'm going to do more examples on my next video.